Hello, everybody. Alex here again. And today we're going over some geometric series exercises. Before we do the actual exercises, there are a couple of things you need to know in order to do these. One of them is you need to know when a geometric series converges. So a geometric series in general looks like the sum of r to the n, where n starts at some value. Usually we make it start at 0. Or we write it as 1 plus r squared plus yada, yada, yada. So depending on what r is, this may or may not converge. And if you recall from lecture, this converges if r is strictly between -1 and 1, or equivalently, if the absolute value of r is strictly less than 1. So the first chunk of each of these exercises is just determining what is the value of r. And if you notice the way that these problems are written out, it's not particularly obvious what the R is. Maybe for number one, it's a little more obvious. And then the second one is, what is the sum of a geometric series? And the general formula is the first term divided by 1 minus r. Or the way this is usually written is, if it converges, the sum as n goes from 0 to infinity of r to the n is equal to 1 over 1 minus r, as long as we're plugging in an r value that makes the series converge. Okay, so for this first sum, you notice there's a couple of things that are different about it from the standard form of a geometric series. Mainly, well, one, it's not some number raised to the n. There's a 2 there that's not raised to the n. And the series starts at n equals 4 and not n equals 0. Now that starting value for n, well, that's not going to affect whether it converges or not, but it is going to affect quite a bit what the value of the sum is. So let's take a look at this one in a little bit more detail. So number one, we're looking at the sum as n goes from 4 to infinity of 2 divided by 3 to the n. Okay, so we want to first of all figure out, well, what is r? Now, so basically we want to rewrite this so it looks more like a geometric series. So it's some junk raised to the n, and maybe there's a constant multiple, like times the r to the n or whatever. And so we can rearrange the inside of this a little bit by factoring out the 2. And so if we rearrange the inside of the sum, we can say this is the same thing as 2 times 1/3 raised to the n. And now it's a little bit more obvious what the r is, right? If we scroll up, the general form is, oh, r to the n. What's the thing being raised to the n? Well, that's 1/3. So here we can see that r is equal to 1/3. And 1/3 is, in fact, between -1 and 1. So absolute value of 1/3 is, in fact, less than 1. So it converges. Now that we know it converges, we can determine what the value of the sum is. And this second formula right here only works if the sum starts at n equals 0. The one above it, where it says, oh, it's the first term over 1 minus r. I'll show you what I mean by that. If we want to use the formula where it starts at n equals 0, we have to screw around with this a little bit. And it might be easier to write out the first few terms of the series and maybe re-index the sum. So write out the first few terms. And I'm going to keep the 2 factored out. So the first few terms would be, if I start at n equals 4, it'd be 2 times 1/3 to the 4th, or actually here, I'll leave the 2 in, plus 2 times 1/3 to the 5th, plus 2 times a third to the 6th plus 2 times a third to the 7th, and so on and so on and so on. And the cool thing about this is, well, we can factor out a 2 times 1/3 to the 4th out of each term. And if we do that, 2 times 1/3 to the 4th times brackets, well, the first term, after we divide that off, becomes 1. The second term becomes 1/3. The third term, well, I guess this would be n equals 0 would be the 1, n equals 1 would be the 1/3, n equals 2 would be 1/3 squared, and then the next one would be 1/3 cubed, and so on and so on and so on. And this thing in the brackets here can be rewritten as just your regular geometric series, where the r is 1/3, and we just have this extra constant out here, 2 times 1/3 raised to the 4th times the sum as n goes from 0 to infinity of 1/3 to the n. Now again, going back up to our formula here, oh yeah, the thing in the sum, that's the sum of r to the n. It converges, so it's just 1 over 1 minus r. So we can replace the summation part of this with 1 over 1 minus 1/3. So we get 2 times 1/3 to the 4th, so that's this constant multiple, and then times 1 over 1 minus 1/3. And we can clean it up a little bit. If we multiply top and bottom by 3, we get 2 times 1/3 to the 4th times 3 over 3 minus 1. And the 3 minus 1 becomes a 2, and so that cancels with the 2 out front. And this 3 will cancel with one of the 3's on the bottom, and so we'll get 1 over 3 to the 4th times 3 over 1, and so we get 1 over 3 cubed, or 1 over 27 is the value of our sum. And so that was using that second formula here, where n goes from 0 to infinity, r to the n is equal to 1 minus r. We could have gotten this a lot faster if we just used this first formula here. It's the first term divided by 1 minus r. Because if you notice, once we know what r is, this thing that we factored out front is just the first term. It's what we get if we plug in n equals 4 into here. So if we equivalently, where can I put this? Here. So if we equivalently use the formula first term, so the first term was 2 times 1/3 to the 4th, and then the r was 1/3, and then our sum would be 2 times 1/3 to the 4th over 1 minus 1/3, which, as we saw before, simplifies down to 1 over 27. Okay, so that's two different ways of evaluating the same sum. Okay, so what about the second problem? Well, that's a nasty looking thing. There's a lot of stuff raised to the n, so it looks like it might be a geometric series. There's crazy things going on in the exponents. There's a 3 to the 2n and not really a 3 to the n, and there's a 2 to the 3n and not really a 2 to the n. So we're going to have to sort of massage this so it looks more like a geometric series. So let's take a look at this. So problem number 2. Sum as n goes from 1 to infinity of 4 times -1 to the n times 3 to the 2n, all divided by 2 to the 3n. And again, we want that same question is what is r, so we know whether or not it converges. And if it does converge, we want to determine what the sum is. Okay, so we want to get this into the form of the sum of like a times r to the n. So some number times some other number raised to the n. Okay, well, there's some annoying things going on in the exponent. So if you might recall a very useful exponent rule that, so, well, we could just 3 to the 2n, that's the same thing as 3 squared raised to the n, which is the same thing as 9 to the n. And we could do the same thing with the 2 to the 3n. So 2 to the 3n is the same thing as 2 cubed raised to the n, and then that's the same thing as, what's 2 cubed? 8 to the n. And so we can simplify this a little bit and say like, well, now our sum looks like this. N goes from 1 to infinity of 4 times negative 1 to the n times 9 to the n over 8 to the n. Okay, now there's another rule, exponent rule, that might be useful here. If I have a to the n times b to the n divided by c to the n, that's the same thing as ab over c raised to the n. As long as they all have the same exponent, when you multiply them, you can sort of group them as all of that stuff raised to the n. So you can see the only thing not being raised to the n here is the 4. And so our sum simplifies to, and goes from 1 to infinity. We have 4. All right, well, negative 1 to the n, 9 to the n over 8 to the n, that's negative 9 over 8 raised to the n. And now we can see what the r is. The r is this negative 9 over 8. So r equals negative 9 over 8. And, oh, that's not strictly between negative 1 and 1. So the absolute value of negative 9 over 8, which is just 9 over 8, that's bigger than 1. That means this diverges and there's no more work to do. So we're done. So the lesson is for a geometric series, first figure out whether it converges or not, which hopefully is pretty easy. Well, I guess there might be a zeroth step, which, you know, if you're dealing with more general series, is it a geometric series in the first place? And once you know whether it converges or diverges, then you can apply that formula in order to determine what the value of the sum is. All right, so that's all I got for today. I hope you enjoyed it, and I will see you guys next time.